Hi, and welcome to Great Expectation Mathematics Tuitions. We are going to continue on our series of learning probability in maths literacy. So let's sit back and enjoy the lesson. So, in our last questions, we looked at probability in terms of applying the formula, and we looked at theoretical and experimental probability. Now we have what we call compound events in probability. This simply means when probability occurs in situations that have more than one event taking place. So we call this compound event. And we can solve these or represent these compound events either by a tree diagram or by two-way tables. Now, what is a tree diagram? Simply put, it is shaped like a tree and it has branches which represent outcomes. So if you look at the sketch there below, a tree diagram would start like that there and then branch out in different branches out there, depending on the number of events that we are considering. But it has this starting point here, and then we have different branches out there. So that is how we would represent a probability and many events through using a tree diagram. The best way to illustrate this is through an example. So John goes to McDonald's and he can choose the following: a burger, which could be either chicken or beef. He could choose chips, small, medium, and large from the menu, and a cool drink or soda, which could be Fanta or raspberry. So how many different combinations can he choose? In other words, if he chooses a burger, chips, and soda, in how many different combinations can he choose from the menu? For example, if we choose a chicken burger, a small chips, and a Fanta, or he could choose a chicken burger, a medium chips, and also a Fanta, or he could choose a chicken burger, a large chips, and a Fanta. But what if we decide to choose a chicken burger, a small chips, and a raspberry drink? So as you can see, it's going to be quite complex representing all those combinations. But the tree diagram would assist us in getting through that very, very easy. So we start at this point and we list the first two choices that he can make, which is a chicken burger or a beef burger. Now, the choices of choosing a chicken burger or beef burger is one out of two choices. Remember our probability formula? The number of successful outcomes over the total number of outcomes. So we have a choice of two burgers, and to get a chicken burger would be one out of the two, or if you choose a beef burger, would be also one out of two. Then, if we look at our next choice, which is the chips, and here we indicate that he could choose a small chips, a medium chips, or a large chips with his chicken burger. So John could have a chicken burger with the small chips, a chicken burger with the medium chips, a chicken burger with the large chips. So that would mean he has one out of three choices for the chips. One out of three. And similarly, we would do the same down here for the beef burger. Coming now to the last choice, which is the cool drink or the soda, he can choose either a Fanta or a raspberry with his small chips. So there we have a chicken burger, a small chips with a Fanta or raspberry. And in this case, for cool drink choices, he has one out of two choices. You will see how we develop it for the other, and we will develop it for each of those other combinations. Now, if we look at the outcome, which they ask us, how many different combinations can he choose? In the first one, he could have a chicken burger, comma, a small chips, and a Fanta. That's just one. Or he could have a chicken burger with a small chips and a raspberry. So in this part here that we follow in the tree diagram, we go up there, down to that level, or that one, down to there. Then John could say, I want a chicken burger with a medium chips, and then he could choose either a Fanta or a raspberry. And so you can see we are building up our combination. So that's a chicken burger, medium chips, but a Fanta, or a chicken burger, medium chips, and a raspberry. And you can see it's building up very nicely. And then we need to answer this question, how many different combinations can we choose? Would you be able to predict that day? I'll give you a few minutes to think about the other ones. You can draw it on your page and look at the different ways of the different combinations that he could be obtaining. If we look at how we would sort this out, here it is. So you look at it and see that the branches are developed. Down here we have the beef burger, small chips and the Fanta, beef burger, medium chips and a Fanta there. And you would see that as you develop your combinations, that John would have a total of 12 combinations for choosing from the menu. He has 12 possibilities of choosing from the menu. You need to develop all and see all the possibilities. If you ask the question, what's the probability that John would choose a chicken burger, a small chips, and a Fanta? Then we follow the first part. There's a chicken burger, it's a half. The probability to choose a small chips, it's 1/3. And to choose a Fanta, it's a half. We multiply that out, we see that the choice, the probability is 1 out of 12 choices. Here we have the total number of outcomes. If he has to choose a combination chicken burger, small chips Fanta, or a chicken burger, small chips, and a raspberry, then we now going to add our two probabilities and we get 2 out of 12. And this, I'm sure you're going to be looking at that and practicing with further examples on that question there. In our next question, we asked to draw a tree diagram to represent the possible outcome of tossing a coin two times. So tossing a coin two times. So this is compounding events. If we want to go through that there, we see that in our first toss of the coin, they have listed it toss one, toss two. You either get a head or tail in a second toss, get a head or tail in the second toss. So if you follow our branches, there's the outcome. Head and a head and a tail and a head, tail and a tail. So there are four combinations. One, two, three, four. The possibility of getting a head and a head, we would follow this route here, and that would be half times half. The possibility of getting a tail, so we go here, and a head, so it would be also a half times half. And likewise with a head and a tail. So it makes work very easier to know our tree diagram representation. Learners, we will practice more with that with past question. Our last part in probability is what we call another way of representing compound events is to look at two-way tables, which is also called a contingency table. It is done as follows, and we have rows and columns. The outcomes are found across the rows and columns. So here we have outcome 1 and outcome 2. And in these blocks will be the values or the possibilities combining outcome 1 and outcome 2. As I said, the best way to illustrate such a table is to look at an example. So in this example here, we have the table shows the results of a survey conducted to determine how many students get to university. How do students get to university on a Monday to Friday and Friday, Monday and Friday, only those 2 days. So here we have the mode of transport, cycle, to use a car, taxi, walk, and a total. In the other column, we have the days Monday and Friday. And here now we can see that on Monday, 12 of them use cycling, whereas on Monday, 42 use the taxi, and on Monday, 20 walk, and the total is 100. But we don't know how many people use the car on a Monday. Let's look at Friday. We go, so all you do is go that way and across. And where they intersect or meet, that would be your outcome. So on Friday, 8 people cycle, right? Just take out that line there. On Friday, 8 students cycle, 50 use the taxi, and the total is 122 students for a Friday. Now our question 1 is to determine A, B, C, D, E, and F from the table. If you look at your rows and columns, it would be easy. It's like playing noughts and crosses, I would say. So to determine A, we have 12 and 8. So obviously the total to find A is 12 plus 8, which is 20. So we get the idea that we need to add the columns or the rows to get to our total. Likewise, to find B, we look at that. We have 12, 42, and 20, and the total is 100. So to determine B, it would be obviously that 100 minus 12 minus the 42 and the 20. And easy one to also get is F. It's a total of the 100 plus the 22, which is 222. So this is a survey that was done, and these are the results of that survey. So let's look at finding A, B, C, D, E, F. There's value for A, B, E, C, D, and F. As we said, F is 222. But now, if we look at question 2.1, they want us to determine the probability that a student taken at random, remember it's all random selection, cycle to university. So cycling to university, we look, there's 12 on Monday, 8 on Friday, and the total is 20. So what is the probability of a person cycling to university? So we have a total number of 20 students. We have the total for the week, which is 222 for that 2 days. So our probability will be, as we go back to the formula, the number of successful over the total number of outcomes. And we would get an answer of 20 over 222, which simplifies to 10 over 111. Student asks, do we need to simplify? Yes, I think you should simplify your fraction. Your calculator would give you the simplified version also. So there is an answer for the number of students cycling. Let's go back. Cycling students, 20. Total number for the 2 days is 222. And that would be the next question. Determine the probability that students did not walk to university on Friday. How many learners did not walk to university on Friday? Now, if you look at Friday and the number of students walking, that would be E. So how many students did not walk on a Friday for only that day there? If we look at our total number of students on a Friday, it's 122. And if we find out that if we look at E, our answer for E is 40 from our previous calculation. So 122 minus 40 would be 82. So 82 students do not walk to university on a Friday out of the possibility of 122. So I'm sure you are saying now your probability for that would be 82 over 122, which would be 41. So 41 there. Let's clear that up there. The 41 just got cut off there over 61. The last question, the number of students travel by taxi or car on a Monday. So if you look at students on a Monday, taxi or car, which is B, and answer for B is 26. Now we can find this that by using the sum of the probability. On Monday specifically, its total is 100. So if we look at the number of students traveling by car was a total of 26, by taxi is 42, and our total for that would be 68. So the probability of learners using the car or taxi would simply mean 68 out of 100 suits, which simplifies to 34 over 50. Cool. So learners, I've given you basic knowledge on probability so that you can use this to now advance yourself and go into the problems in past exam papers and questions on probability, having known all the different aspects of probability. So I wish you well, and we will meet again in our next uh, series on probability, which would be past question. Bye for now.